All right, let's talk about one of the most powerful and maybe one of the most feared ideas in all of programming, pointers in the C language. But trust me, by the end of this, you're going to see that they're not nearly as scary as they sound. In fact, they're kind of brilliant.
So, what's the central problem that pointers are trying to solve? Well, usually in programming, we're all about a variable's value. The number 10 or the letter A. But what if you need to work with the variable's location, its actual spot in the computer's memory? That's the question pointers answer.
So here's our roadmap. We're going to start with a really simple analogy to get the basic idea down. Then we'll get into the two key tools you need to make it all work. After that, we'll see why this is so powerful in the real world. And finally, we'll wrap up with the key takeaways and what to watch out for.
Okay, first things first. To really, truly understand what a pointer is, let's just forget about code for a minute. Let's think about something we all deal with every day. A mailing address. Think about it, right? An address, like 123 Main Street, isn't the actual house. It's just a little piece of information that tells you where the house is. If I have the address, I can find the house, I can send something to the house. The address is just a reference. The house is the real thing. And this is a perfect analogy for how a computer's memory works. Every single variable you create in your code, it has to live somewhere. It gets its own little slot in memory, and that slot has a unique address. A pointer, then, is just a special kind of variable designed for one job, to hold on to one of those memory addresses. And that's it. That's the core definition right there. You know how a normal integer variable holds a number, like 42? Well, a pointer to an integer doesn't hold 42. It holds the address of where the number 42 is being stored. It's a variable that points to another variable. Okay, so we've got the concept down. Now, let's look at the actual tools. C gives us two very special operators to work with these addresses, and they are basically your entire toolkit for pointers. And here they are. First, you've got the ampersand, and. You can think of this as the address of operator. It's how you ask the question, hey, where does this variable live? Then you have the asterisk, star. This is the dereference operator. This is how you say, okay, I've got an address, now go to that address and tell me what value is stored there. Let's just walk through this simple piece of code. First line, easy. We create an integer called x and we stick the number 10 in it. Then we declare a pointer called p. That little asterisk tells C, hey, p isn't a normal integer, it's designed to hold the address of an integer. And then the magic happens on that last line. We say p equals and x. We're telling the computer, go find the address of x and store that address inside my pointer p. And just like that, p is now pointing to x. So if p just holds the address, how do we get the actual value, the number 10, back out? Well, that's what the asterisk is for. When we put the asterisk in front of p, like star p, we're no longer talking about the address. We're saying, go to the address that p is pointing to and grab me the value you find. And since p is pointing right at x, it grabs the value 10. And this leads us to something incredibly powerful. Once you have a pointer to a variable, you don't need the variable's original name anymore to change it. You can do it indirectly through the pointer. Now check this out. Look at that line, p equals 20. Remember what p means. It means the value at the location p points to. So by setting star p to 20, we're actually reaching into the memory slot for x and changing its value. That's why when we print x at the end, it's no longer 10, it's 20. We changed x without ever typing its name. Okay, so changing things indirectly is pretty cool, but why is it so important? Where's the real game-changing power here? Well, it all comes down to how different parts of your program, especially functions, talk to each other. So, here's a classic problem in programming. In C, by default, when you pass a variable into a function, the function just gets a temporary copy. It can do whatever it wants to that copy, but as soon as the function is done, that copy is thrown away, and the original variable outside is completely untouched. So, how do we get around that? And the solution is just beautiful. Instead of passing the function a copy of the value, we pass it the address of the original variable. Look at the code. We don't call increment x, we call increment and x. We give the function the location of x. The function catches that address in its pointer called num. Then, inside the function, it uses star num to reach all the way back out into the main function and directly change the original value of x. It's a total game changer. And really, that's the whole point. Pointers let us break down the walls between different parts of our code.
Instead of making lots of inefficient copies of data and passing them around, different functions can all operate on the exact same piece of data in memory. This is absolutely essential for writing fast, efficient code.
All right, let's bring this all home. We'll do a super quick recap of what we learned, and then I'll point out a couple of the most common traps that people fall into when they're first learning about pointers.
So, let's just nail down the 4 most important things. 1. A pointer stores an address. 2. The ampersand and gets you an address. 3. The asterisk, star, gets you the value at an address. And 4. Their real superpower is letting functions modify the original data. You get those 4 things, and you've got the core of it down. Now, with great power comes a couple of classic ways to shoot yourself in the foot. First, never ever use a pointer that you haven't initialized. An uninitialized pointer is basically pointing to some random garbage spot in memory, and trying to use it is asking for trouble. Second, never try to access the value of a null pointer. Null literally means this points to nothing. So if you try to get a value from it, your program is going to crash, guaranteed. And that really brings us to the final thought. We've seen how pointers work, but it's worth taking a second to think about why they matter so much. This ability to directly work with memory is the secret sauce behind C's legendary speed and power. It's why C is used to build operating systems, game engines, and all sorts of high-performance software. It's a powerful tool, and now it's one you understand. Thanks for watching.